How are you guys doing? We are approaching the end of the semester, just the last week of classes. Unfortunately, we could not complete the semester in class, but hopefully this video is helping you out a little bit. So we just have section 6.5 and 6.6 left for this week, and 6.5 is actually rather short and simple, and it's a good section to refresh our memory on some of the stuff, and hopefully it'll help you to reinforce some of the other stuff and to understand it a little bit better. First of all, again, this is the important rules which you should know, and they should guide you through the entire chapter 6. Remember, we have the following 4 compound propositions: P and Q, P or Q, if P then Q, and P if and only if Q. Now, let's remember the rules for them, something you should know. In case of P and Q, you have to remember one particular situation, and you have to remember it very well. It is if both of them are true, then the result is also true. If both are true, then the result is true. In case of P or Q, there is only one situation as well, and that is if both of them are false, then the result is false. There is also one situation for implication, conditional statements. If P then Q, what is it? Again, if we're going from true to false, then the result is false. In all other cases, it is true. And finally, remember the last situation, P if and only if Q, which is the identity. We have 2 situations here. That's the only one we have to remember, 2 of them. If both of them are true, then the result is true, and if both of them are false, then the result is also true. Now, this is important to remember, because this is essentially how you do, like I said, the entire chapter 6, and in particular 6.5. So let's just look at 6.5. Let's look at one of the examples. How do you do it? Okay, so this is our example. It is from the book. This is the argument we have, and we have to check whether it's valid. Proving validity. Now, prior to this point, we were drawing tables trying to get all the possible situations, right? But in this case, it's not really necessary, because you can actually use the rules you just learned in order to figure it out very quickly. This is how you do it. You just write it down, again in line, like we did in 6.4, right? Okay, this is the same argument. What do you do in order to figure out whether it is valid? And remember, this is checking for validity, so we want to know if it's valid. Now, what would be the situation if it's not valid? Remember, what is a valid argument? If premises are true, the conclusion is always true. So, if it wasn't valid, the situation will be true premises and a false conclusion. So let's just write it down. This is what we should get as a result if we go through step-by-step process and discover that it is invalid. We should get true here, and false here. Okay, let's use the rules we know and see what does this kind of force our values to be. We can immediately see that. For example, well, right here, in order for this premise, not B, to be true, what B is supposed to be? Well, B, of course, is supposed to be false, right? So we have the value for B. B has to be false. Now, how about here? If C then A and it is false. Well, remember, implication is only false in one situation, isn't it? And that situation is if we have true here, and false here. So in order for it to be false, C has to be true, A has to be false, and B has to be false. There you go. Note that we actually have all of them, don't we? Okay, now let's check further. And what we're looking for here is a contradiction. We're looking for a situation where it's not possible. Because if it's not possible, that will tell us what? That the argument is valid. Because it's not possible for us to get invalid situation. Now, what is it here? Okay, let's see. Can we have this premise with this particular values, B being false, C being true, and A being false, and get true result? Now, if B is false and C is true, what is the value here? Well, remember, it's only false if both of them are false, right? So it is actually true. Now, how about not A? A is false, so what is not A? Well, it actually is true too. Oh, look, there's no contradiction. We actually got it. What did we just prove? We proved that there is a situation when you can have true premises and false conclusion, which is by definition invalid. We've proven it invalid. Now, what would be the situation if it is valid? Well, we would never get this. So there would be a problem. I'm not going to go through this next example, which you can see in the notes, but you can see it there yourself. It gets to the point where you simply can't get these values to work. The rule's not allowing you to. And for this reason, you can see that it is invalid. Now, let's look at the example of checking for consistency. In this case, instead of getting everything true and the conclusion false, we just need to get all of them true, right? If every premise can be true in the same time in at least one situation, then the whole thing is consistent. Otherwise, it is inconsistent. We're applying the same principle. So now again, we wrote down what we need to get, and we will see, using the rules, how do we get there. Now, once again, if we have true here for the premise of not A, then A obviously would have to be false, right? Now, what else can we get here immediately? Well, there is a number of situations which you can have for implications in order to get it true, right? There is also a number of situations which you can get for disjunction in order for it to be true. But we already have value for A, right? So that helps us a little bit. We know that A has to be false. Now actually our option for this first premise is narrowed down to 1, isn't it? I mean, look at it. In order for the whole thing to be true, if A is false, what B has to be? Well, clearly it would have to be true. So we found another value. B has to be true, A has to be false. Otherwise, it's not going to work. Now let's try to plug it in here and see how that works. Now we know that our B has to be true, so not B has to be false. Then we can't have truth here, can we? Because if you're going from true to false, you would get the whole thing false. So we clearly only can have false here. So we found our C. Now we have all of them. Now let's try to work with this last one and see if it actually works for us. We'll use a different color for that. So we already know that C has to be false. We already know that A has to be false. Therefore, C or A would have to be false, right? Now B, on the other hand, we know has to be true. So we know this is true, we know this is false. Uh-oh. We need the truth here, but we don't get it. So what does it mean? It means we actually don't have that kind of situation which we were looking for. It means it is inconsistent. Okay, I didn't want to make it too long for you. Hopefully that is again clear enough and enough for you to understand it. We have just one lecture to go on 6.6, which is one of the most important, so I'm not going to waste too much of your time. Again, if you have any questions, please email me or message me. Otherwise, this is the 6.6.